precisamente lo que nos va a contar hoy en la charla de hoy es, sobre todo, los varamientos de cetáceos que tienen en esa zona de Escocia, que comparado con los nuestros son pues 100 veces más, prácticamente, o 30 veces más. En la costa vasca nosotros tenemos al año entre 30 y 40 varamientos de mamíferos marinos y en Escocia sobre 1000 más o menos al año. Hombre, la costa escocesa es bastante más larga, tiene más recovecos que la nuestra, pero aún así el esfuerzo que tienen que hacer los investigadores de allí es muy importante. Entonces, Rebecca nos va a contar precisamente eso, ¿no? Pues cómo gestionan, cómo trabajan y qué información son capaces de obtener de los animales que han varado en las costas escocesas. Una lección para aprender nosotros de ellos que tienen mucha más experiencia que nosotros.
So first of all, since I have no idea who everyone is, I thought I'd give a little bit of a background. Marine mammals are essentially much like humans. They're warm-blooded, they're air-breathing, they give live birth, they do parental care, they have strong cognitive abilities, and in some species, very complex social structures. So they're these incredible animals. But we can break them down a little bit further into cetaceans, which are your whales, dolphins, porpoises, and then all the other ones are seals, sea cows, polar bears, and otters. Cetaceans you kind of split up a little bit as well by their, essentially by their teeth. So you have baleen whales, which rather than having teeth the way we do, have these sheets that are made out of the same material as hair and fingernails, and they essentially squish water out through these baleens and capture all the krill and the fish they eat, which means that they spend a lot of time diving and feeding, which will come into play a little bit later on. And then you have your toothed whales, which are all the other ones. So your delphinids, your killer whales, pilot whales, your dolphins, your porpoises, so your small fat dolphins, and then beaked whales, which just to me, they look incredibly hilarious, but they're really cool animals as well. So to me and many other people, marine mammals in science are incredibly interesting because they sit at the top of an ecosystem that is really hard for us to study. We can't dive long enough to understand how this entire marine system works, but because they integrate these food webs both over space and time, because they live for so long and they feed on all these different animals, we can learn a lot about the environment through them. And they show us the effects of cumulative impacts like pollution, like climate change, habitat degradation. And they essentially act as this early warning system for something's wrong out there. And that's really important, especially nowadays with all the different things that we've sadly done to this planet, that we need to understand, and that hopefully gives us a chance to change things and to protect the environment. I wanted to introduce the UK stranding scheme because these people make all this work possible, and they help researchers all across the UK and Europe by handing over their samples and their experience. The UK has a big coastline, so we've kind of split up the country by England and Wales, being covered by the Cetacean Strandings Investigations Programme, led by Rob DeVille in the red shirt and his team, Rosie, Simon and Matt. And then in Scotland, we have the Scottish Marine Animal Stranding Scheme, led by Andrew in the yellow jacket, together with Marielle and Nick. Both organizations were started in the 90s, in the early 90s, so they have about 3 decades worth of data and of knowledge and samples. Together, they have something like 200,000 tissue samples from stranded marine animals and 20,000 necropsy reports and information about where strandings have happened. So that alone is already, to me, really incredible and something that I wish other countries could have as well, but in many cases it's an issue of funding, of accessibility to the sites. So I'm really happy that I can work with these people. They obviously rely a lot on volunteers to go out and to call in when they see a dead mammal, so that they actually know it's happening, but also on trained volunteers to go out and collect samples, take pictures and give them the information. So citizen science for us is a really big thing as well. Moving on, I thought it would be probably most interesting to talk about what we can actually learn from these animals other than about the animals themselves, because of course we can use them to learn about the physiology and all sorts of things, but how can we use them as a bigger picture? So they can tell us things about climate change, about warming oceans. They live in these really diverse ecosystems that depend on these fine-tuned parameters to not change. So what can we learn from that? They can tell us a lot about environmental pollution. This is one of the most polluted killer whales that we have found to date. She was also the last female killer whale that we had in Scotland as a resident. So with that, there is a population that's now going extinct. And lastly, and I'm saving this for last, although it is sad to see, but there is a hope story in this, entanglement and the human use of offshore environments. We really can use these animals to learn where there is interactions and how we can mitigate these problems. Both in the UK and in Germany, where I'm originally from, every year for the last 10, 15 years on the radio, you will hear, this is the hottest summer since the recording of temperatures. And it just gets warmer and warmer every year, and you've kind of gotten used to that statement. But the same thing is happening in the ocean. So this is where the UK is, up there is Scotland, and essentially this is, in 2023, in the summer, the waters were 4 degrees warmer than they were on average between the 1980s and 2016. So that means that these animals are living in waters that are now 12 and not 8 degrees, which for me, liking the warmth, is a good thing, but for them that leads to a lot of problems. So the very first thing that happens is thermal stress. They have a really thick layer of blubber, which is like fat that is there to insulate them, but it's also involved in their hormone regulation. So this needs to be there and it needs to protect them. And when they're in cold waters, it protects them from the cold temperatures and it keeps their organs safe, but they need to use a lot of energy to cool down if the waters around them are becoming warmer. And this becomes even more important when they start doing things like hunting, like reproducing, or when they're in like growth stages of calf development. So suddenly the energy that they used to have to defend themselves or for their immune system, they need to use to cool down. That only becomes worse when you start thinking about the fact that warming waters also means that their prey availability changes. So suddenly you will either have a shift in what kind of fish species you find in the oceans that might be less optimal for these whales and these dolphins. So they're in a less good nutritional condition and they still need to use all their energy to cool down again. Or they need to start hunting further away or deeper into the ocean to get those species that are optimal for them, which again means they need a lot of energy and then they need to cool down. On top of that, you might have changes in seasonality of the spawning of fish. So they might still be there, but they're available at a different time in the year that no longer matches up with things like weaning their offspring or reproductive seasons. So that as well can be a big stressor. And then the last thing is also that whilst they're already battling with all these problems, you then have warming waters that lead to the increased prevalence of parasites, and that is something that they could usually fend off quite well. But if all the other things are already happening and you put contaminants and noise pollution into the mix, it becomes really stressful for these animals. Moving on to pollution, this is something that I work on a lot, together with some of the people in the stranding scheme as well. By doing necropsies on these animals, post-mortem assessments, and analyzing the tissues, we can determine what the burden of contaminants, such as heavy metals or plastics, are in these animals and how it gets into the food web. But it also means that we can start to understand whether our production and waste management is effective or whether we need to address problems at the source. This is work that was done by Rosie Williams. Obviously, it's a team effort. And she was looking at all the samples she could find of various different marine mammals over time and space in both the Scottish and the English database. And she was looking at persistent organic pollutants, which, if you aren't aware of them, are things like fire retardants or your non-stick pans and plasticizers and all these fancy things we've come up with to make our life easier. Some of them have been banned, but not all of them, and even the ones that have been banned are already out there, so we still need to measure them. And the problem is, once they're in the environment, they don't break down, and they accumulate in fat. Marine mammals have a lot of fat, so they accumulate a lot of these contaminants. And obviously that's interesting in and of itself, but it would be even more interesting if we could figure out what the actual impact in the animals is. So she tried to look at how we can link the concentration that we measure in these animals with the risk of them dying of an infectious disease because their immune system isn't working properly anymore. That is one of the main things that these contaminants do, is they disrupt your hormonal system and they impact your immune system. And she was able to show that as of current samples, with every 1 milligram increase of contaminant measured in these animals, they are at a 5% increased risk of dying of an infectious disease. If you now think that some of the killer whale samples that we had were at a concentration of 900 milligrams per kilogram, you can think of how high that risk for that animal was. So in the UK context, these findings show that we still need to look at the management of these contaminants, and we need to keep reinforcing it and keep that conversation going. But we were only able to figure that out because we have access to this incredible treasure trove of samples and experience within our stranding schemes. In Scotland, entanglement is actually one of the main causes of strandings for baleen whales. We've had about 160 cases since the beginning of the stranding scheme, 50 of those within the last 5 years. So there seems to be an increase in recent years. And these are only the cases that wash ashore and where we can tell that they are caused by strandings. If the animal is too decomposed or if it sinks to the seafloor and we never see it, we can't record it. So there might be a lot more than this. So we also figured out that one of the main industries or the main gear that these animals are entangling in is creel pods. They're essentially little kind of pods that are baited so that we can catch lobster, prawn, and kind of like the picture on the top, they have one buoy at the end and then they're attached to one another with a line that runs near the seafloor, but it floats a little bit. And that is usually where marine mammals will get caught. And because those things are quite heavy, that then stops them from coming to the surface. Considering that they're air breathing, they do have to come up. So essentially, that's how, in many cases, they die. But at the same time, creel fishing in Scotland is very traditional. It's one of the lower impact and kind of more environmentally friendly approaches that we have, especially if you compare it to, for example, dredging or trawling. And it's a very important industry for our coastline, considering that about 2,000 people have their livelihood attached to this industry. And they are custodians of the sea. Many people in this industry that you talk to, they love the ocean. They don't want to catch whales. So this is something that they are as keen on working on as we are. And that is kind of how the Scottish Entanglement Alliance came about, which essentially aims to understand the scale and the impact of this, but also find a solution for it. And they were able to find a solution, which, if you think about it from when I tell you what the solution is probably quite obvious, but hindsight is 2020, so, it was a bit of a finding process. They just use heavy ropes. They use leaded ropes that sink to the seafloor so that there's nothing to get caught on. And this is something that might sound very easy, but if you consider that this is a fishing industry and that these people who are on the creel boats, they make a living off of this, so it had to be tested. And what the Entanglement Alliance did was they went out and they got about 100 fishing boats signed up to this trial and said, here's the rope, put it out to the test, run as many trials as you can, see if it works with your equipment, see if it's too heavy and suddenly you need to use more fuel, see if there's any problem elsewhere that we aren't spotting because we need this to work for you as much as we need it to work for us. And this is, I think, the only way that we can solve problems like this, is if we work together and if we don't come from the, well, I'm a scientist, I know the answer approach. But if we go, okay, I have an idea, but I'm not in the field, I don't know if this works. Luckily, this idea worked really well. Other than the fact that the rope is slightly more expensive than what they usually used, it worked really well. So right now, we're pushing for the government to subsidize this so that we can make this vital industry for the Scottish coastline even more sustainable and keep it alive. And they are all really keen to be on board with this because they love whales as much as we do. They don't want to see them dead.